In last class, we have completed the method of preparation of alcohol. I think in last class we have done preparation of alcohol from Grignard reagent. Now, write down preparation of alcohol by the use of reducing agents. By the use of reducing agent. In general, we use lithium aluminum hydride, sodium borohydride, these two reducing agents to prepare alcohol from carbonyl compound. Let's say there is a carbonyl compound C double bond O. When we react it with lithium aluminum hydride, we know lithium aluminum hydride breaks in the form of Li plus and AlH4 minus. Lithium aluminum hydride is useful because of bond between aluminum and hydrogen. You can see aluminum forms 4 different bonds with the hydrogen. Aluminum forms 4 different bonds with the hydrogen. And between aluminum and hydrogen, aluminum is electropositive. So the electron always moves towards hydrogen and it is a good hydride donor. It is a good hydride donor. So in carbonyl compound, we know that the carbon and oxygen, there is a pi bond and a sigma bond. A pi bond are weak bonds. So oxygen element attract electron towards itself and partial negative charge is generated in oxygen and partial positive charge in carbon. Lithium aluminum hydride breaks in the form of Li plus and AlH4 minus. In the first step, aluminum hydride react with this carbonyl compound as a hydride donor H minus. As a hydride donor H minus. Now this aluminum form 4 bond, therefore the aluminum is negatively charged because it forms 4 bonds. When one H minus is released from aluminum, this aluminum negative charge is converted to neutral, not positive. Right? So it is a hydride donor. So when H minus approaches this carbon, this aluminum forms 3 bond and aluminum become neutral as well as a strong Lewis acid. So when this H minus attack to this carbon, both the electron are attracted by this oxygen and oxygen is converted to full-fledged negative charge in place of partial negative. Now this negative charge now attack to the Lewis acid aluminum which forms 3 bonds, right? So the first step is like this. C, this is hydrogen, oxygen, aluminum form 3 bond and aluminum is negatively charged. Okay. So if in the question we give lithium aluminum D4, this carbon is isotopic. Hydrogen की जगह क्या आएगा? Deuterium. So if I treat it with AlD4, in place of hydrogen, one deuterium will approach, right? Again, the aluminum is now negatively charged. So now one more equivalent of carbonyl compound can be approached by this aluminum hydride. So one more H minus attack to this carbon and oxygen get negative charge. This oxygen is now attacking to the Lewis acid aluminum and the structure will be like this. CHO, these type of 2 AlHH minus. 2 oxygen containing compound attack the aluminum and there are 2 hydrogen, right? So this molecule can now attack to one more carbonyl compound in which this is a hydride donor and this oxygen get negative charge which is opposed to the aluminum. This is the third step. OCH whole thrice H minus. So last one more carbonyl compound. This H minus will attack to this. Finally, it is converted to for aluminum when this is treated with acidic water. H plus will attack to the oxygen because it consists of partial negative charge. And aluminum will be approached by OH. So the final product will be and aluminum hydroxide. Aluminum hydroxide. If you mechanism, it is the four-step reaction kinetic. First, let's say K1, second K2, third K3, fourth K4. This is not the partial step. Actually, we have divided the four reaction into four chemical kinetics: K1, K2, K3, and K4. Finally, this carbonyl compound is converted to alcohol. Now, in the first step, the rate determining step or the slowest step, you can say, is the H minus donor. In the first step, H minus is eliminated from AlH4. From AlH4, but in place of hydrogen, if you put oxygen, which is more electronegative, it attract electron towards aluminum. So the removal of this H minus will be slower. So can I say easily H minus can be donated by AlH4, right? And it is difficult to remove hydrogen from the K4 part. So the according to kinetic, K1 will be the fast, then K2, then K3, then K4. So fastest reaction is K1 and slowest reaction is K4. Why K4 is slow? Because it consists of electronegative element, and all electronegative element withdraw electron from aluminum, and it is electron deficient, so it is difficult to remove one H minus. That means we can able to convert aluminum hydride is a strong reducing agent. You can able to reduce the reducing power by eliminating hydrogen with oxygen. That means if I have two reducing agent, one is LiAlH4 and second is LiAlHOTBU whole 3. So between these two, which is strong reducing agent, LiAlH4, because in this molecule, 3 electronegative elements are attached with aluminum. So it is difficult to remove this H minus. That means in this reaction, the fastest reaction is K1. And if this hydrogen is isotopic, the carbon which is attached with oxygen consists of the isotopic hydrogen. In place of hydrogen, if you take D4, in place of this hydrogen, there is one deuterium. So this is all about the lithium aluminum hydride reduction with carbonyl compound. So almost all carbonyl compound can be reduced by lithium aluminum hydride. Almost all carbonyl compound are reduced by lithium aluminum hydride as well as sodium borohydride. Now, there are different type of carbonyl compound. For example, formaldehyde, aldehydes, ketones. These three carbonyl compound are the carbonyl compound which are hydride acceptor. So can be converted to alcohol. First molecule can be converted to methanol. Second molecule can be converted to primary alcohol. Third molecule can be converted to secondary alcohol. But if the carbonyl compound consists of some leaving group like ester, OR is the leaving group, like acyl chloride, Cl is the leaving group, like carboxylic group, like anhydrides. So there are three molecules which consist of leaving group except OH. Except OH, almost all are leaving group. When these molecules are treated with lithium aluminum hydride, when H minus attack to this carbon, this oxygen get negative charge. In general, what we do, this negative charge attack to the aluminum part and the reaction proceeds, right? But when the leaving group is present, this O minus shows a plus R effect and the leaving group is eliminated. For example, when lithium aluminum hydride is treated, the H minus will attack to the carbonyl compound C and it is converted to O minus and H, and this is OR. Now the plus R effect of this O minus removes this OR group and it is converted to aldehyde, and we know that aldehyde also react with the lithium aluminum hydride to reduce to form alcohol. So one more H minus attack to this carbonyl compound and it is converted to alcohol. So we can say that almost all leaving group will approach from this mechanism. Between lithium aluminum and sodium borohydride, the strong reducing agent is lithium aluminum hydride. The strong reducing agent is lithium aluminum hydride. Lithium aluminum hydride can able to reduce almost all functional group. But unable to reduce alcohols. It can also reduce alkyl halide. Lithium aluminum hydride can also reduce alkyl halide. Alkyl halide must be primary or the alkyl halide must be secondary, but tertiary alkyl halides, lithium aluminum hydride cannot reduce. If you give tertiary alkyl halide, lithium aluminum hydride convert tertiary alkyl halide to alkene, but for primary and secondary it is converted to alkane. Second thing, between lithium aluminum and sodium borohydride, both are the strong reducing agents. Still they are unable to reduce unsaturated hydrocarbons like alkene and alkyne. If you treat lithium aluminum hydride with alkene and alkyne, they are not reduced. But if the alkene or alkyne are in the benzylic position, that can be reduced by lithium aluminum hydride. Is it clear? If you read any alkene and react it with lithium aluminum hydride, we can say no reaction, right? But if any double or triple bond are at the benzylic position and this molecule is treated with lithium aluminum hydride, this double or triple bond can be reduced to alkane. This double and triple bond can be reduced to alkane. But in general, the alkene and alkyne are not reduced by lithium aluminum hydride. Now, second, talking about the sodium borohydride, it can able to reduce formaldehydes, it can able to reduce aldehyde, ketone, but esters and carboxylic acids are not reduced by sodium borohydride. These are the two molecule or two carbonyl compound which cannot be reduced by sodium borohydride. Rest all can be reduced by lithium aluminum hydride as well as sodium borohydride. So this is the third method of preparation of alcohol. Clear? Talking about the chemical properties of alcohols. Chemical properties of alcohols. This is the structure of alcohol. If we are talking about the chemical properties, alcohol undergo different type of reaction based on the different type of bonds. It consists of a polar bond, O and H. Yes. So one type of reaction is it can give H plus, but this is a very weak acid. This is a weaker acid as compared to water. So, but if you treat it with strong conjugate base, this H plus can be replaced. So one kind of chemical property is associated with this hydrogen being an acidic hydrogen less than water, right? The second property is due to this bond. We will break carbon and oxygen bond because this bond is again polar bond. Oxygen is more electronegative, can take both the electron from carbon, generate positive charge. So alcohol shows two type of properties, one due to this hydrogen and second due to this carbon and oxygen bond. So let's talk about this hydrogen. Can we say this hydrogen is a polar and protic hydrogen. So can react with base, strong base. But this hydrogen is a weak acidic in nature. So we required a strong base. So there are very few elements which can able to remove this hydrogen. Out of that, first is metals like sodium, lithium, sodium, potassium. These are the metal which can able to reduce or eliminate this hydrogen. When sodium react with alcohol, we know that the sodium are electropositive in nature. So these sodium can give one Na plus and electron, and the polar hydrogen, that is oxygen and hydrogen, both hydrogen electron can be taken by this oxygen and oxygen get negative charge. This negative and this positive can form bond. It form a salt CH3, CH2, O minus and Na plus. And this electron is accepted by this hydrogen. This H plus when accept one electron form H radical. Two H radical combine to give hydrogen gas. So it form half molecule of H2. So this is one kind of test also to check whether the molecule is consists of polar or active hydrogen or not. So when sodium is treated with alcohols, it produces hydrogen, which is a positive test for OH group, which is a positive test for OH group. And the second reagent which can react with this active hydrogen are Grignard reagent, CH3, Mg, Br. We know that the Grignard reagent consists of CH3 minus, which is a strong base, strong conjugate base. So this CH3 minus being a strong conjugate base can easily remove this hydrogen. So when Grignard reagent is treated with alcohol, this acidic hydrogen can be eliminated by this CH3 minus and form methane gas, and this MgBr attack to this oxygen. So with Grignard reagent, can we say the molecule forms CH3, CH2O, MgBr plus CH4 gas plus CH4 gas. So Grignard reagent react with this alcohol to eliminate the hydrogen. We can say this Grignard reagent is also useful to check whether the molecule consists of how many polar or protic hydrogen. The method to check whether the molecule consists of number of polar or protic hydrogen is also known as Zary-Witnow's method. For example, if there is an unknown molecule, the structure is not known to you. For let us see this example: OH, H, CH2, C, C double bond O, OH, CH2, CH2OH. Let's say the structure is not known to you and you want to calculate number of polar protic hydrogens present in this molecule. So what will you do? You take 1 mole of this molecule and treat it with methyl magnesium bromide or any other Grignard reagent, methyl magnesium bromide excess, right? And this molecule you have taken is 1 mole. If this molecule consists of 0 polar hydrogen, the methane produced after treating excess of Grignard reagent will be 0. Now, this molecule consists of how many polar hydrogens? 1, 2, 3, 4, 5. So, when this molecule, 1 mole, treated with excess of methyl magnesium bromide, it will produce 5 moles of methane. So number of moles of methane produced by 1 mole of unknown molecule equals to number of polar or active hydrogen present in that particular molecule. So we can able to check whether this molecule consists of how many polar or active hydrogens. So these are the two reagents which react with the polar and active hydrogens. The second chemical property starts with the cleavage of carbon and oxygen bond. Carbon and oxygen bond. Carbon and oxygen bond cleavage start with even reaction mechanism, which you have already completed in the chapter of alkene. Right? This molecule CH3, CH2, CH2OH. When this molecule is treated with H2SO4 at elevated temperature, the H plus attack to the oxygen, right? The oxygen is now converted to OH2 plus, In the second step, water is eliminated and carbocation form. Shifting of carbocation to the most stable space, hydride shift. After that, we can able to remove one hydrogen from the alpha carbon and it form alkene. We can say when this alcohol is treated with H2SO4 and high temperature, it give alkene, which is known as elimination or dehydration of alcohol. Now, this dehydration is a strong competitor of SN1 or SN2 reaction mechanism. So this product is actually E1. This product is E1. Now, if we reduce the temperature and at low temperature, this OH2. Now, this OH2 is a good living group. And we have taken excess of alcohol, right? And we know that oxygen consists of lone pair, so it acts as a nucleophile. So, as this oxygen accept these two electrons, this lone pair can attack to this carbon. So it form a molecule which is substituted or ether forms, right? This ether formation may occur through SN1 or SN2. It depends upon the type of alcohol which we are using. That means when alcohol is treated with H2SO4 at high temperature, possibilities are E1 and SN1. Both E1 and SN1 are competitor of each other. But if you see in their reaction, in E1, there are higher number of cleavages of bond and formation because this is a carbon and oxygen bond cleavage occur, hydride shift occur, one carbon hydrogen bond cleavage occur, carbon-carbon bond formation occur. So number of bond cleavage, number of bond formation are higher in case of E1. But in SN1, the number of bond formation and cleavage are lower. So SN1 is kinetically controlled product, whereas E1 is thermodynamically controlled product. That means if you increase the temperature, E1 product will be the major. If you decrease the temperature, SN1 or SN2 product are major. Is it clear? So this reaction can be controlled by the help of temperature. Third part of OH group reaction is esterification. In esterification, carboxylic acid react with alcohol. Carboxylic acid react with alcohol in presence of H plus to form ester. To form ester plus water. Plus water. H plus act as a catalyst after the reaction. The H plus pH remain constant. Clear? So carboxylic acid react with alcohol in presence of H plus to form ester and water. Here H plus act as a catalyst and this reaction is in equilibrium. This reaction is in equilibrium. So if you want to prepare ester, you will take non-aqueous medium. You will take non-aqueous medium. What will you do? Just you add carboxylic acid in alcohol in presence of H plus. So the medium must be alcoholic. So you can able to use Le-Chatelier principle. In presence of excess of alcohol, the carboxylic acid react with this alcohol to form ester. But if you want to prepare carboxylic acid and alcohol from ester, what will you do? You will add this ester in acidic water. So according to Le-Chatelier principle, when the water is in the excess form, the entire reaction goes to the backward direction. But almost all ester reaction are in equilibrium and it is a pseudo first order reaction kinetics. Simple. Now, how this mechanism proceeds. First, if you take acidic medium, we know that the carboxylic acids are weak acid. We know that the carboxylic acids are weak acids. So, if you put weak acid in the acidic medium, H plus cannot be removed from this oxygen because we have already added H plus and the reaction or the equilibrium of dissociation of carboxylic acid goes to the backward direction. and this H plus can attach to the lone pair. No, the lone pair are available in the both the oxygen, right? But you know, the difference between these two oxygen is this oxygen is sp3 hybridized, whereas this oxygen is sp2 hybridized. Now we know that higher the S character, higher will be the electronegativity. Higher will be the electronegativity, higher will be the electron accepting power. Second point is that this lone pair undergo resonance with this double bond. If this lone pair shows a plus R effect, both the electron goes to this oxygen and this oxygen consists of 3 lone pairs. So based on the electronegativity, based on the plus R effect of this OH group, can we say that the oxygen which are double bonded consist of higher electron density as compared to the oxygen which is single bonded? Now, if the lone pair availability are higher at this oxygen, we can say this H plus can attach this oxygen. This is what we call protonation of carboxylic acid. Now this H plus, if to this double bonded oxygen, this double bonded oxygen get positive charge, having one lone pair, right? Now, if this oxygen get positive charge, that means electronegative element get positive charge. If electronegative element get positive charge, it is highly unstable. So it can take both the pi cloud. If both the pi cloud are accepted by this oxygen, that means this carbon is partial positive. Now it converted to full-fledged positive. So nucleophilic addition can take place, not nucleophilic substitution. Because in nucleophilic substitution, we used to say nucleophile is substituting certain group. In this case, nucleophile is adding to this carbon, right? So after this reaction, alcohol attacks this oxygen. Alcohol having lone pair can act as a Lewis acid. Sorry, alcohol having lone pair can act as a Lewis base as well as a good nucleophile, approaches this carbon, right? And both the electron are taken by single bond OH. So this structure is converted to OH, OH plus R and OH. See, this carbon is highly unstable due to the formation of two bonds OH-OH. If I remove this OR, this become gem diol, and gem diol are highly unstable. So this molecule, entire molecule is highly unstable. If this molecule is highly unstable, so what happened? It undergo intramolecular proton exchange. Intramolecular proton exchange means both the electron, this oxygen is accepted by this oxygen and this H plus will be free. Now this H plus attack to the single bond OH and it is converted to OR. This oxygen get positive charge, right? Now OH is not a leaving group, but when OH is protonated by H plus, so H2O become a good leaving group. If H2O become a good leaving group and this oxygen consists of lone pair, the plus R effect of this lone pair can remove this OH group. So after this, it forms C double bond O H positive. This is OR plus H2O. As we know that this oxygen is more electronegative, therefore one H plus is removed. One H plus is removed. Can I say here the one H plus is removed and in the first step one H plus is absorbed. So number of H plus absorbed and number of H plus released are equal. Therefore, after the reaction, the pH remain constant. I have drawn this equilibrium. I have drawn this entire reaction mechanism in an equilibrium form. So if we want to show the mechanism of ester react with water in presence of H plus, it goes backward direction. For example, this is the ester. This is ester. Let's say we have taken non-aqueous medium. That means we have taken aqueous medium. We have added water in this reaction. So if I add water, ester and H plus, so this H plus will attack to this double bonded oxygen due to same reason which I have explained in this point, right? So this H plus will attack to this oxygen. So this oxygen get positive charge. Now both the electron are accepted by this oxygen and this water attack to this carbon, form this one. Now again the intramolecular proton exchange occur and this H plus move to this OR, and the plus R of effect of this remove this alcohol, and the reaction goes backward direction forming alcohol and carboxylic acid. Simple. Now, if actually this entire reaction is in equilibrium, but still the most important reaction is addition of alcohol to the carbonyl compound for both forward as well as backward reaction. So this step is the slowest step. So if you want to control the rate of reaction, we have to see the reaction mechanism of this particular step. In this step, the attack of oxygen lone pair to the carbonyl compound are rate determining. So that means we are saying that nucleophilic addition of the alcohol is the rate determining step. So nucleophilic addition is highly affected by the steric hindrance. So can we say that primary alcohol, the rate is very high as compared to secondary, as compared to tertiary? So if the alcohol nature is changed, the esterification rate will be changed. Secondly, the carbonyl compound also affect the rate of reaction. So we can say formic acid esterification is higher as compared to acetic acid, as compared to propanoic acid, as compared to benzoic acid. So if you increase the steric hindrance in carbonyl compounds or carboxylic part, the rate will decrease. Both happen with the alcohol as well as with this carboxylic group. So this is the esterification in which we have taken alcohol and carboxylic acid. Two are the different molecules. So this esterification is also known as intermolecular esterification, because alcohol and carboxylic acid are different. There are intramolecular esterification also there, in which alcoholic group and carboxylic group are simultaneously present in a single molecule. In the intramolecular esterification, the cyclization of the ester form, and we prefer 5-member, 6-member ring. Simple. Is it clear? CHCl3, CHF3, CHI3. CHF3 is known as fluoroform. CHCl3 is known as chloroform. CHI3 is known as iodoform. That means CHI3 is iodoform and it is a yellow crystalline precipitate. And this is a very important test of alcohol. Clear? So if CHI3 form in any chemical reaction, it give a positive test for alcohol. It give a positive test for aldehyde also. It give a positive test for ketone also. So iodoform test is alcohol, ketone as well as aldehydes. Clear? So let's discuss the mechanism of iodoform test. Primary alcohol, and this primary alcohol is reacted with sodium hydroxide and iodine. It forms CHI3 and HC double bond OH. In some cases, CH3CO Na is also written because carboxylic acid cannot be present in sodium hydroxide. So in sodium salt form. After hydrolysis, I have got formic acid. So CHI3, if CHI3 form, that means it is a positive test for alcohols. So this is a primary alcohol. This is primary alcohol. So all primary alcohol having at least 3 alpha hydrogen. This is alpha hydrogen. At least 3 alpha hydrogen give positive test for alcohols. Clear? Now, what is the mechanism of this reaction? First of all, this primary alcohol CH3 CH2OH is treated with iodine. We know that iodine is a weak oxidizing agent. Iodine is a weak oxidizing agent. This iodine can able to oxidize primary and secondary alcohol to carbonyl compound, but unable to oxidize tertiary alcohol. Iodine is a weak oxidizing agent. It can able to oxidize primary alcohol. It can able to oxidize secondary alcohol, but unable to oxidize tertiary alcohol. And iodine cannot oxidize any carbonyl compound. That means aldehyde and ketone are not further oxidized. So if you take iodine with CH3CH2OH, in the first step of this reaction, this iodine oxidize this primary alcohol to aldehyde and convert it to I minus. See, 0 to I minus, that means it is accepting electron. Accepting electron means it is reduced. It is reduced means it is oxidized. Clear? But this carbonyl compound is not further oxidized unless we can able to get the carboxylic acid in this point. So this alcohol react with iodine to form aldehydes and I minus. In the second step, this CH3 C double bond OH. Now the OH minus, we know that OH minus is a base. OH minus is base. Now, if somebody compare between the nucleophilicity and basicity, almost all bases are nucleophile, and reverse is also true. OH minus act as a nucleophile. OH minus also act as a base. Is it clear? OH minus act as nucleophile as well as base. Now, if you can able to see this OH minus in this molecule act as a nucleophile, then it must attack to this carbon. If it act as a base, it must attack to this hydrogen. Yes. Now, what is the difference between nucleophilicity and basicity? Nucleophilicity and basicity can be defined as, for example, we have a X minus. We have X minus. If this X minus combined with H plus, it gives HX. If this X minus combined with C plus, it gives CX. Yes or no? Now assume that this X minus we add in a container, one equivalent X minus we have added in a container. It consists of one equivalent of H plus, one equivalent of C plus, one equivalent of X minus is added. If this X minus combined with H plus in presence of C plus, so we will say the affinity of X minus is more towards H plus. So this X minus act as base. And if this attack to this C plus and it forms CX, I will say X minus is a nucleophile. So what is the difference between nucleophile and base? Nucleophile are the species which have more affinity towards carbon. That means if X minus and C bond form, 100 joule of energy is released. And if X minus form bond with H, minus 10 joule of energy is released. So we will say the affinity towards C minus C plus is higher with X plus. So X minus must act as a nucleophile. So if you want to compare between the nucleophilicity and basicity, you have to understand the bond energy. So you cannot able to remember almost all bond energy. So one more factor which you can able to compare, one more, that is that I am assuming that this is a nucleophile. I am assuming that this X minus is a nucleophile. So the X minus is a nucleophile. So affinity towards this C plus must be higher as compared to the H plus. Now, if I put this X minus in a container which consists of H plus as well as C plus, this X minus will combine with C plus. Now you add this X minus in a container which consists of only H plus. Then it will combine with H plus. So can I say almost all nucleophile act as a base in the absence of C plus? Reverse is also true. So how we define the nucleophilicity and what are the factors which affect this nucleophilicity and basicity? The most important factor is the steric hindrance. What is that? Steric hindrance. For example, this is a RCl. In SN1 and SN2 reaction, you have already completed the nucleophilicity with RX, right? So if I say in R, if I treat RCl with OH minus, see OH minus, CH3O minus, CH3CO minus, CH3O minus, right? When it react with RCl, In SN1, SN2 reaction, you have already completed that negative charge intensity is the important factor for nucleophilicity. One thing. Second, nature of solvent play a very important role in the nucleophilicity. Third thing, the polar aprotic and polar protic solvent, which solvent you are taking. Fourth thing, the nature of this species, positive, negative, right? Now, see, as I move down the group, the plus I effect increases, the negative charge in the oxygen increases. But the problem is that if you increase the negative charge in an atom, the nucleophilicity and basicity both increases simultaneously. But if I say a base, OH minus base, so base have to approach in the hydrogen, right? Base is a substance or negative charge which have to approach in the hydrogen, whereas the nucleophile is a negative species which has to approach in the carbon, and we know that carbon form 4 bonds. Carbon form 4 bonds, but hydrogen form 1 bond. So in hydrogen, steric hindrance, if some negative species have to attack in the hydrogen, steric hindrance has no role, because hydrogen form 1 bond. That means all the steric hindrance only in the one part, second part is only open. But if nucleophile has to attack in the carbon, it form 4 bonds. It form 4 bonds. So if the groups are bulky, the nucleophilicity may decreases. Steric hindrance play a very important role in the judgment of whether the nucleophile or base, the negative charges. So as we move down the group, the negative charge increases, both nucleophilicity and basicity increases. But as we move down the group, the bulkiness increases, therefore the nucleophilicity decreases and basicity increases. Therefore, if I treat this RCl with KOH, aqueous KOH, the attacking species is OH minus, which act as a nucleophile. But if I treat KOH in presence of alcoholic medium, the attacking species is O minus CH2CS3, which is a bulky base. Sorry, which is a bulky group. So it acts as a base. So undergo E2 mechanism. So alcoholic KOH give SN2, whereas aqueous KOH will give SN2 and alcoholic KOH give E2. Clear? This molecule, when treated with KOH of water, it acts as SN2, right? That means this OH minus act as a nucleophile, yes? But this RCl, when treated with KOH and C2H5OH, the attacking species is C2H5O minus, which is bulky. There will undergo, I am telling that it prefer E2, but the E2 and SN2 are also controlled by the factor temperature. So if you reduce the temperature in this, it may undergo SN2. Simple. Now, in this molecule, the attacking species is OH minus, and as we have already completed nucleophilicity, OH minus is a nucleophile or base. OH minus is a nucleophile or base. It is a very good nucleophile. It is a very good. But in this case, if I will attack OH minus as a nucleophile, I have to attack this OH minus to this carbon compound. And if OH minus will attack to this carbon compound, it form a gem diol. It form a gem diol, and we know that gem diol is highly unstable and the equilibrium goes to the backward direction. So OH minus being a strong base, still it act as a, being a strong nucleophile, still it act as a base, because if it act as nucleophile, it form gem diol, which is unstable, but if you make this gem diol stable, then OH minus must act as nucleophile. So in this case, because gem diol are unstable, therefore OH minus act as a base. So OH minus will remove the alpha hydrogen, and it forms CH2 minus C double bond OH. Right? This negative charge is more stable than this O negative charge due to the resonance. Now, iodine I2, this negative charge attack to this iodine, and CH2I, C double bond OH, this form. Again, the OH minus approaches this hydrogen, because this hydrogen is much more higher acidic as compared to this hydrogen due to the presence of iodine, which is electronegative element. So this OH minus remove this hydrogen, and one negative charge is generated to this alpha position. Due to the iodine, this negative charge is stabilized. Not due to the minus I effect of this iodine. This iodine forms p pi d pi bond, which stabilizes the conjugate base. Right? So this negative charge is stabilized by p pi d pi bond of this iodine. Now another molecule of iodine, this negative charge attack to this iodine, it forms CiI C double bond OH. This hydrogen again is more acidic, and the OH minus attack to this hydrogen, and it forms Ci3 C double bond OH. Is it clear? Which part? OH minus is nucleophile or base? Nucleophile. If it is a nucleophile, I will attack to this carbon. If it acts as a nucleophile, I attack to this carbon, it forms gem diol, which is unstable. That means that is the ineffective collision. Now, this is being a strong nucleophile, but cannot act as a nucleophile because of the formation of gem diol. Now, this OH minus act as, so it will remove alpha hydrogen. If it remove alpha hydrogen, it get negative charge in the alpha hydrogen. So it is CH2 minus. Now this CH2 minus attack to the iodine because I have taken excess quantity of iodine. So this CH2 attack to this iodine and I minus is removed. This I attach this carbon. Now this carbon consists of 2 hydrogen. These 2 hydrogen are more acidic than these 3 hydrogen due to the presence of iodine and due to the presence of carbonyl compound. Now if OH minus remove this hydrogen, this negative charge is stabilized by the resonance of carbonyl as well as the iodine p pi d pi bond. Now again this I minus attack to the iodine. One more iodine is attached. This hydrogen is more acidic. So OH minus again remove this hydrogen and it's converted to Ci3CHO. Now it is clear. Now look at the last molecule which I have written. This is Ci3 C double bond O H, and now again OH minus, right? We know that OH minus is a nucleophile. Still OH minus act as a base in this reaction due to gem diol formation and not the stabilization of that particular gem diol. But in this molecule, see this OH minus, if act as a nucleophile to this carbonyl compound, now the gem diol can be stabilized due to the leaving group of Ci3. So can I say this OH minus can approach to the carbon? Yes. This is O minus and OH. Now this plus R effect of this O minus can remove both the electron from this and it forms formic acid. Yes. Plus Ci3 minus. Now this Ci3 minus, this accept this H plus and convert it to CHI3, which is a yellow precipitate, and give a positive test of iodoform. Is it clear? All other center, is it clear? If you have any doubt, post your questions. I am coming to that question which you have asked. Methyl group is necessary to show whether it form a positive iodoform test or not. Actually, if you see the mechanism, the question which you have asked is presence of CH3 group is necessary or not, right? Look, if somebody asks you CH3 CH2 OH, give iodoform test positive or not, If I will give you a questions or a solution that carbonyl compound having carbon consists of 3 alpha hydrogen will give positive test. This is not the correct explanation of a iodoform test, because if I will say you presence of 3 hydrogen is a sufficient condition to show iodoform test, then the iodoform test questions can be solved easily by saying that alpha hydrogen consists of 3 hydrogen, that is a positive. There are different type of group which consist of 3 hydrogen but give negative iodoform test. There are some cases which consist of 3 hydrogen but give positive test. So there are all type of example. You have to consider this mechanism. If the given molecule, can form CHI3, I will say the molecule show positive iodoform, right? It may possible that it consists of 3 hydrogen. It may possible that it consists of no 3 hydrogen. Simple, clear. So can I ask some questions? Should I rub the board? So I am coming to the last question. The groups which are present shows iodoform test positive or negative. I'm writing some molecule in this board. You have to write which molecule shows positive iodoform test with your own mechanism. You have to show that the molecule, if you are saying that that particular molecule showing positive iodoform test, that means you are saying that from that molecule we can able to prepare CHI3. Clear? So first 7. Write down which molecule shows positive iodoform test. So all center post your answer which molecule from 1 to 7 shows positive iodoform test. KV7 is not the correct answer. So let's start with the first. Why first is not showing positive iodoform test? You know, if I treat this molecule with iodine and NaOH, this molecule can be oxidized to form CS3, CH2, C double bond OH in the first step, right? In the second step, the OH minus can attack to this hydrogen and it form a negative charge in this carbon. So it is difficult to remove the hydrogen because of the plus I effect of this methyl, but still this strong base can remove this hydrogen. It can form Ci2 OH, right? And this is not a leaving group. And it cannot form Ci3 because of the methyl group presence. So this molecule can never show positive iodoform test. Clear? But in the second case, if iodine oxidizes the second part, this molecule can be converted to ketone, right? Now this carbonyl compound having 3 alpha hydrogen can be replaced these 3 hydrogen by iodine. So it form Ci3. Now the OH minus can act as a nucleophile and remove this CHI3, and this CHI3 form CHI3 precipitate. Yes. So it gives positive iodoform test, right? Third, positive or negative? Why negative? Perfect. Because it is a 3-degree alcohol which is not oxidized by iodine. So this 3-degree alcohol are unable to oxidize by iodine because iodine is a weak oxidizing agent. So it gives negative iodoform test. Now see fourth, positive or negative? Why negative? Why this is negative? It consists of 3 hydrogen. So it is positive or negative? ऑक्सीडाइज करने की जरूरत कहाँ है? कार्बोनाइल कंपाउंड हमें चाहिए था, वो है. So this is not question about the oxidation or reduction. This is a question about that when you treat iodine and NaOH, whether the molecule give an CHI3 or not, right? For example, if this molecule upon oxidation give ketone, and this ketone when treated with iodine, it can form CHI3. So this molecule give negative iodoform test. Why? Because you know that in this molecule, if I treat this as like this, in iodoform test, the final product you are forming this, right? OH minus act as base or nucleophile in this molecule. Say it has alpha hydrogen. Now in this molecule, this OH minus act as base or nucleophile. Why it is base? Because there is a leaving group. What is the leaving group? Ci3. Why Ci3 is the leaving group? Because this negative charge in the carbon is stabilized by the 3 iodine, isn't it? This is a good leaving group, or Cl minus is a good leaving group. Cl minus is a good leaving group. Carbon negative never will be more stable as compared to Cl minus, right? So now see this molecule. Does it require Ci3? It consists of a good leaving group Cl minus. Now OH minus act as base or nucleophile? Nucleophile. It replaces this Cl and form carboxylic acid, right? Therefore it gives negative iodoform test. C double bond OH aldehyde. सब कुछ ठीक है? Positive iodoform test. Positive iodoform. Negative iodo due to presence of leaving group. Clear to all? Should I rub the board? Clear? So again, Out of this 5 molecule, which molecule shows positive iodoform test? Out of these 5 molecule, which molecule shows positive iodoform test? All other centers, you can post your answers. KB, sir, acetic acid. How you can say that acetic acid can form iodoform? You see, acetic acid consists of CH3COOH. When you treat this NaOH and iodine, iodine cannot able to oxidize or reduce, but NaOH can give C double bond O minus. So OH minus replace this hydrogen and form sodium acetate. Now this group shows plus I effect, so this hydrogen cannot be removed by OH minus. So acetic acid give negative iodoform test to the presence of CO minus, which is a plus I effect, and the CH3 hydrogen is not an acidic. KV only one. First shows positive, rest all negative. Kendriya Vidyalaya Navlakha, there are some more molecule which shows positive iodoform test, which is written in the board. Apart from first. First is the correct answer. Fifth नहीं रहेगा. Four is not the correct answer. Fifth करेगा. First, positive or negative? Why positive? Because it consists of 3 hydrogen. Listen carefully. Why you are saying first positive? Because you can able to see that the carbonyl compound consists of 3 hydrogen at this position, right? But tell me, when the first is treated with OH minus, this OH minus will replace this hydrogen or this hydrogen? This OH minus replace this hydrogen or this hydrogen? This one? No. क्यों? ये क्यों नहीं? अगर तुम इससे निकालोगे तो ये नेगेटिव चार्ज का एक सिंगल रेजोनेंस आ रहा है, बराबर? यहाँ पे नेगेटिव चार्ज इज स्टेबलाइज्ड बाय द बोथ द कार्बोनाइल ग्रुप, द माइनस आई इफेक्ट एज वेल एज द माइनस आर इफेक्ट. सो इस हाइड्रोजन को एलिमिनेट करेगा. ठीक है, अब आंसर बताओ फर्स्ट होगा कि नहीं. So the OH minus will attack to this carbon, this carbon instead of this one, and it consists of 2 hydrogen. So it shows positive or negative. Negative bolo. So first give positive iodoform test. Why? See, in the first molecule, when it is treated with OH minus, in presence of iodine, you can able to form this step, right? Yes or no? Replacing OH minus with this hydrogen treating iodine, you can form this molecule. Okay. Now, again OH minus. Can I say this OH minus can act as a nucleophile in this molecule because it consists of a leaving group which is stabilized by the resonance as well as the minus I effect of the iodine, p pi d pi bond of the iodine. Now the third step, this OH minus act in the carbonyl compound as a nucleophile, and the plus R effect of this O minus replace this as a nucleophile, sorry, as a leaving group. Ci2 minus double bond O CS3. Yes. Now this negative can react with iodine to form Ci3 C double bond O CS3. Yes. Now the OH minus again act as a nucleophile, and finally you will get CHI3. Yes. So first molecule showing positive iodoform test by OH minus, because OH minus act as a nucleophile in the two different steps. सिंपल. इसलिए इसको ऐसे याद रखना कि 3 हाइड्रोजन होंगे तो पॉजिटिव होगा, सही नहीं है. तुम्हें मैकेनिज्म ड्रॉ करना है. अगर आप उस मॉलिक्यूल से CHI3 बना पाते हो, पॉजिटिव है. If you are unable to form CHI3, it gives negative. So you have to draw the entire mechanism of almost all molecules, right? Clear? So second, positive, negative. Second, which hydrogen is replaced by OH minus? This hydrogen or this hydrogen? This hydrogen or this hydrogen? Never. Carboxylic acid are almost 10 times more acidic than this one. Have you seen that? Methane was giving H plus in the aqueous medium, but carboxylic gives. So in the second give negative iodoform test at room temperature, but positive iodoform test at high temperature. The second, the iodoform test is depends upon the temperature. Why I am saying depends upon the temperature? In the second molecule, the structure is like this: C double bond O, CH2, C double bond O, OH. Yes. Now the OH minus attack to this hydrogen. If OH minus attack to this hydrogen, it gives this one. Now why I am saying temperature? If you heat this molecule, it undergo decarboxylation. It undergo decarboxylation, eliminates carbon dioxide. Now this carbon negative approaches iodine, forms CHI2. Now this CHI2 further reacting gives CHI3, and then OH minus act as a nucleophile in this carbon, and CHI3 can be precipitated out. So give positive iodoform test after removing carbon dioxide. But to remove this carbon dioxide, we required high temperature because decarboxylation occurs at higher temperature. Yes, but this decarboxylation may occur at the lower band of temperature because of the stability of this carboanion. रूम टेम्परेचर में CO2 गैस अगर नहीं निकलती है तो नेगेटिव है. ये तभी तो पॉजिटिव देगा जब CO2 बाहर निकलेगा. CO2 निकलने के लिए टेम्परेचर तो बढ़ाओगे, तो थोड़ा टेम्परेचर बढ़ाओगे CO2 निकलेगा. अगर नॉर्मल कार्बोक्सिलिक से CO2 निकालना है तो बहुत ज्यादा टेम्परेचर चाहिए. इससे कम टेम्परेचर में निकल जाएगा क्योंकि नेगेटिव चार्ज स्टेबल है. तो डीकार्बोक्सिलेशन हर उस मॉलिक्यूल की फास्टर होती है जब आप कार्बोएनायन को स्टेबलाइज करते हो रेजोनेंस से. Clear? So, third, positive or negative? Third, room temperature, high temperature, any temperature. Positive, negative. It gives negative iodoform test in almost all temperature range. Why? Because see, in the third structure, it is like this. Right? After removing hydrogen by NaOH. If OH minus remove this hydrogen, this oxygen get negative charge. Now before decarboxylation, this negative charge attack to this carbonyl compound, right? And it is like this. It reacts with water to form a lactone. This lactone consists of a hydroxy group which is tertiary, which is unable to oxidize by the iodine. It is the Angela lactone. due to the formation of this lectin, it gives negative iodoform test. Clear? So first give positive iodoform, second positive at high temperature, third negative due to the formation of this lactone. Right? Fourth positive or negative. आज ही बताना है. Negative. Why negative? Because if I replace these two hydrogen, यहाँ पे दो iodine तो आ सकते हैं, third iodine तो आ ही नहीं पाएगा. So it is a simple case of fourth. Fourth is negative. Fifth, उल्टा बोलोगे. Fifth, negative, positive. So fifth, why fifth is positive? Say the structure of fifth is like this, right? If I treat this iodine, OH minus and iodine, this hydrogen is more acidic. So this hydrogen can be removed. It gives negative charge. This negative charge is approaches by the iodine. We can easily form double bond to iodine, right? There is one more hydrogen which can be easily removed due to the minus I effect of this iodine. So two iodine can be easily approachable. Now, due to this two iodine, this carbonyl compound is now become a good nucleophilic attack. So the OH minus attack to this carbonyl compound, and it give the plus R effect of this compound can replace this molecule, and it will be like this. Ci2 minus, this minus except one iodine converted to Ci3. Now this Ci3 again OH minus attack to this carbonyl compound. This Ci3 will be replaced and form CHI3. Clear? So it gives positive test. Clear? To write up the board. Be clear? So last question. So I'm writing a single molecule. You have to write down whether this molecule shows positive iodo or negative iodo. This shows positive or negative iodoform test. All other center, post your answer in yes or no. If you are writing yes, that means it shows positive iodoform test. Positive or negative? Negative or okay, some are posting that the answer is yes. That means it shows a positive iodoform test, right? Okay. So it shows positive, yes. If I write down the ketonic form of this molecule, it looked like this, right? This is a enol and this is ketone. Now, if I react this molecule with NaOH and iodine, can you say in the two-step reaction mechanism, it is converted to this molecule. OH minus replace this hydrogen, iodine approaches this hydrogen, again OH minus replace. So we can able to add 2 iodine, right? After that, OH minus can act as a nucleophile. OH minus can act as a O minus, OH, I2, I2, double bond O, double bond O. Yes. Now the plus R effect of this oxygen. Plus R effect of this oxygen. Double bond O, OH, double bond O, Ci2 minus. This Ci2 minus now react with iodine. Gives Ci3. OH minus now approaches this carbonyl compound. OH minus now approaches this carbonyl compound. The plus R effect of this O replace this Ci3. Now this negative accept one hydrogen. CCHI3. Simple. So it is very difficult to understand the iodoform test with this manner that the alpha hydrogen, 3 hydrogen, if it will be positive or negative, right? You have to do all the mechanism. I have not added the isotopic effect in the iodoform test. I can able to ask you a question regarding the isotopes of carbon as well as isotope of iodine, and then I can able to ask which isotope will approaches to which carbon. Is it clear to all? Simple? No. How difficult? Some other chemical properties of alcohol are the reaction of alcohol with PCl5, PCl3, SOCl2. But all these 3 reactions we have already discussed in chemical kinetics, right? So I'm leaving these part. Now, there are some more tests of alcohol like Victor-Meyer test, ferric ammonium nitrate test, CAN test, and we will do after phenol, these 2 tests. So let's start with the preparation of phenols. Method of preparation of phenol. If you want to prepare phenol, one of the best method is phenol with diazonium compounds. Preparation of phenol by diazonium compound. This is nitro group, SnHCl. SnHCl reduces nitro group to aniline. Reduces nitro group to aniline. Now this aniline, when treated with HNO2 in presence of H+, HNO2 in presence of H+. See, benzene ring is rich in electron. As we know that benzene ring is rich in electron. First point. Second point is that if benzene ring is rich in electron, So between electrophile and nucleophile, which molecule will attack in benzene ring? Electrophile. Now I have treated HNO2 in presence of H plus. HNO2 in presence of H plus. Can we say that HNO2 in presence of H plus, the structure of HNO2 is like this? Now, if we treat this H plus, it remove water, yes, and generate NO2 positive. NO, sorry, not NO2, NO positive. NO positive is electrophile. Benzene is electron rich. Due to presence of lone pair in the nitrogen, the electron density is benzene ring is much higher as compared to benzene. Aniline is approximately 1 lakh times more reactive than benzene. And this is the electrophile, right? But there are two options. This electrophile approaches to ring, or this electrophile approaches to this nitrogen, because it also consists of lone pair of electron, right? So will this N plus will attack to this carbon or benzene ring, or this N attack to this nitrogen? Nitrogen बचपन से पढ़ा है. Because the bond between N and C and N and N, the bond energy is higher in N and N. Therefore, it attacked to the nitrogen. So if it attacked to the nitrogen, it forms compound like this. Okay, nitrogen positive. Now I am coming to the intramolecular proton exchange. Intramolecular proton exchange. Again, if I remove water, it forms benzene diazonium chloride. Why I am saying chloride? Because this plus and Cl minus are in the solid form. This is benzene diazonium. Benzene diazonium. The only molecule which react with nucleophile and introduces nucleophile in the benzene ring at room temperature. This is benzene diazonium chloride. This is the only molecule which react with nucleophile, and nucleophile attack to the benzene ring at room temperature. So we will see the preparation of phenol with diazonium, right? See, this is benzene diazonium chloride. And because we are preparing phenol, so this molecule is treated with any basic medium, NaOH or KOH or anything else. If I treat this molecule with sodium hydroxide, NaOH, the first step of this reaction is this nitrogen accept both the electron and form positive charge in the benzene ring. This type of positive charge is very rare in benzene, because this positive charge is present in the plane, whereas all the 3 pi bonds are above and below the plane. All the 3 pi bonds are above and below the plane, and this positive charge present in the plane. So this positive charge is not undergoing any resonance. Now, this positive charge, when treated with OH minus, it gives phenol. Okay. This positive charge, when treated with OH minus, it gives phenol. If I am saying that I have 3 different type of nucleophile, A, I have CS3 minus, B, I have OH minus, C, I have Cl minus, A, B, C. Which nucleophile the rate is maximum for this above reaction? This reaction is also known as SN1AR. Substitution nucleophilic first order aromatic compounds. So between A, B, C, which nucleophile the rate is maximum? Other center, you can able to post your answer. A, B, C, which nucleophile the rate is maximum? Cl. Okay. Rest all. एल्काइल हैलाइड तो दिया ही नहीं है. Someone saying Cl, someone saying CS3 minus. Now OH minus is left. See, if I am saying that between A, B, C, which case the rate is higher? Which case the rate is higher? So first you have to understand that between first and second, which step is the rate determining? Between K1 and K2, which step you think it is the rate determining step? Why K1? Because in this molecule, the bond between carbon nitrogen form and the intermediate C plus form. Can we say that changing the nucleophile will alter the K1? No. That means with respect to nucleophile, the order is 0. That means this reaction is not depend upon the nature of nucleophile. So the order of all three are same. All three are same. It is not depend upon the nature of nucleophile. That's why I have written SN1AR. One means first order with respect to benzene diazonium. Okay. So the rate is entirely controlled by the bond cleavage between carbon and nitrogen. The bond cleavage between carbon and nitrogen. In K1, there is only one thing happening. That is carbon, between carbon and nitrogen, the bonds are heterolytically cleavage. The C and N bond heterolytic cleavage is the rate determining step. If any group attached with this benzene ring, decreases the bond energy, must increase the rate of reaction. Yes. So putting one group para position to this benzene diazonium. Now there are one A is methyl, B is NO2, C is OCH3, and D is CCl3. First A methyl exhibit plus I effect, NO2 exhibit minus I minus R, OCH3 exhibit minus I plus R, CCl3 exhibit only minus I. These are the four different type of groups. So you have to tell that between A, B, C, D, which group exhibit higher rate of reaction. Here the answer is not equal, right? So you have to write A, then B, then C, then D. So post your answers greater than sign. Post your answer in terms of greater than sign. A, B, C, D, right? Which case the rate is higher? Nand Vidya Niketan, think once more. The answer is not correct. KV Ahmedabad, the answer is not correct. Post your answer once more. तुम्हारा भी गलत. CABD means highest rate will be with C. Yes or no? Highest will be C. I am asking Nand Vidyalaya Niketan. Nand Vidya Niketan, highest rate will be C. No, then the answer is incorrect. Then no. Some other options? KV Patamo. It is again incorrect. Again incorrect. So I think almost all option you have posted. but still the correct one is not there. Anyone else? Capital letter, again incorrect. ACBD is also incorrect. Any other option? No. DPS incorrect. So now you can able to see the post and you can able to change the answers also. KV Amritsar again incorrect. If it is decreasing, you know, if you are saying that B is highest, then it is incorrect. Tirupati is also incorrect. So I think the probability is also completed, right? No. Still no one posed the right answer. यही बचा था. Okay. The correct answer is A, then D, then B, then C. A, D, B, C. Right? Why? And why the y plus R is decreasing? अगर कोई चीज प्लस आई से बढ़ रही है तो प्लस आर से तो बहुत ज्यादा बढ़ेगी. Actually, what happened in this entire reaction mechanism? The only one thing which is counting is that the bond cleavage between carbon and nitrogen, right? Any group which push electron towards nitrogen, any group which push electron towards nitrogen can decrease the bond dissociation energy and increase the rate. Clear? Okay. If I put methyl group in this position, methyl group is the electron donor. It donates electron and the electron are pushes towards nitrogen and the cleavage is easier. So the rate is higher. Any group which withdraw electron through minus I, minus R or through minus I, pull electron towards carbon and the electron are coming towards carbon, that means the bond energy required is higher. Now what happened with OCS3? In OCS3, it shows a plus R effect. It shows a plus R effect and the bond which we want to break is converted to a double bond, which is difficult to break. Therefore, the answer is A, D, B, C. So can we say in SN1AR, the group which shows plus I effect are the only activators. So SN1AR, if you want to increase the rate of reaction, only plus I group are there. So plus I increase the rate of reaction, rest all decreases. Is it clear? Clear? Any doubt? So to prepare phenol from diazonium compound, we have to add NaOH in diazonium and we can able to prepare phenol. And different group may have different effects. So next method of preparation of phenol from cumins. When benzene is treated with propene in presence of H plus, I think this is a Friedel-Graf reaction. H plus attack to the alkene and both are accepted by this carbon, it is negative. H plus attack to the negative and the carbocation attack to the benzene ring through the electrophilic substitution reaction and it form cumin. Cumin consists of one benzylic hydrogen, right, which is more reactive to the resonance of this benzene ring. Now this cumin, when treated with O2 in presence of photon, quantized photon, which is used to break the pi bond between O and O, बिल्कुल बनेगा. it gave O radical, and this O radical react with this H radical due to the resonance. So this PH C CH3 CH3 radical plus O radical OOH. Now these two radical combined with each other to form peroxy bonds, right? Now this peroxy bond when treated with H plus, this H plus attack to the OH group so that dehydration can occur. Now this is converted to OH plus. If water is removed, it forms O plus and H2O. Now between O plus and C plus is more stable, and the shifting of methyl and phenyl, the phenyl shifting will be higher. So can we say that there is 1-to phenyl shift? There is 1-to phenyl shift, and the OH attack to the positive part. The plus R effect of this O remove the leaving group of OPH, and it is converted to acetone and phenol. So this is a good method to prepare phenol. Simple. Any doubt? Phenol can also be prepared from some other method like benzene. When benzene is treated with water, it forms phenol. We have already discussed benzene. Second, electrophilic substitution. Some part of electrophilic substitution, you can able to prepare phenol, right? So all these reactions of electrophilic and benzene we have discussed in alkyl and aryl halide, right? So let's start with properties of phenol. Chemical properties of phenol. Like alcohol, phenol also show different type of properties, mainly due to this hydrogen, because this is a acidic hydrogen, right? Phenol and carboxylic acid, which is more acidic? Between phenol and carboxylic acid, which is more acidic? One, two, which is more acidic? Why two? If you say the negative charge, it undergo two type of resonance, O negative, O negative. If you see this negative charge, it undergo 4 resonance, 1, 2, 3, 4. Which is more acidic? Carboxylic. You know why resonance? It formed 4 type of resonance. It formed 2 type of resonance. Still, this is more acidic. This answer is very simple. If I ask you C negative, O negative, which is more stable? Perfect. Why? Because it is more electronegative. The concept is that higher the electronegativity, higher will the stability. And if you compare this, now we are going to compare with O negative. It consists of 1 O negative and the resonance 3 C negative. In this molecule, there is both are O negative. 2 resonance, 4 resonance. Now 3 C negative, the negative charge is reduced to 1/3. And here the negative charge reduced to 50%. Still this negative is more stable because electronegative elements negative are more stable. One reason. Two reason, between similar resonance, the resonance energy is higher. So the negative charge, I can say, if I ask you a question that there is a negative charge and this is the resonance, right? and there is a carbon negative charge and it consists of a negative. See, this negative charge undergo 4 resonance, right? So this negative comes to the 4 different carbon atoms, 4 different carbon atom. So here the negative charge present 25%. How many percent? 25%. Reduced to 25%. The negative charge undergo 2 type of resonance. The negative charge reduced to 50%. Now this 50% is more stable as compared to the 25% because it is C negative. If I reduce to 10%, still this is more stable. Clear? Therefore, between phenol and carboxylic acid, which acid is more acidic? Carboxylic acids. Now, in the chemical property of phenol, we will consider the acidic nature of the phenol because almost all reactions react with this oxygen 1. And second, phenol consists of benzene ring. Phenol consists of benzene ring, and we know that benzene ring is rich in electron. We know that benzene ring is rich in electron. That means the lone pair plus R effect, it activates this benzene ring. So electrophilic substitution reaction. Electrophilic substitution reaction. So phenol shows 2 type of chemical property. One, due to this acidic hydrogen. Second, due to this activated benzene ring which undergo electrophilic substitution reaction. Simple. Now, how this activate this benzene ring? You know, if I treat alkene with Br2, we know that Br2 undergo alkene to give 1,2 addition, anti-addition. But if you treat bromine with this benzene, the addition reaction or the electrophilic reaction is not occur. Why? Because benzene ring is less electron dense as compared to this alkene one. And second, this is the aromatic ring. This lone pair activate this benzene ring and the electron density in benzene ring is increased. And this is sufficient to break the bromine. So we don't require any electrophile. AlCl3 or any Lewis acid. AlCl3 and the benzene ring, the bromine may attack in the 3 position. So phenol exhibit mainly two type of reaction. One due to this hydrogen and second due to benzene ring. Clear? So let's start with the first reaction of phenol. Write down the product of this reaction. AlCl3 is a Lewis acid. Oxygen consists of lone pair. So this Lewis acid attack to this oxygen. And this oxygen get positive charge. Both the electron are accepted by this oxygen and it is converted to this compound. You can see this is the electrophile can attack to the para position because ortho position there is a steric hindrance between OCl3 and it gives OCS3, right? This is known as Fry's rearrangement. This is known as Fry's rearrangement. And Fry's rearrangement are of 2 types basically. One is intramolecular, other is intermolecular. The reaction which I have shown in this board is intermolecular because the bond is cleavage. Other is intramolecular, which is take place at high temperature more than 160 degrees centigrade. This temperature is the low temperature, therefore intermolecular. Right? This is not a reaction, this is a rearrangement because we are rearranging this product to this compound, right? Clear? So we'll continue from price rearrangement in the next class. Right? Thank you.
हाँ मैं कर रहा हूँ। जी सर, दे रहा हूँ। सर टाइम हो गया सर, टाइम हो गया।
हाँ बस कर दे रहा हूँ ये क्या क्या कवर किया हुआ है बस। और कोई बात नहीं। चलो देखते हैं। एक मिनट रुक जरा। So I'm here to discuss with you, see, an application of the derivatives, monotonic functions, inequalities, monotonic functions and inequalities, right? You see, we begin with talking about, say, Lagrange's mean value theorem, and that states that if f is a real valued function defined on closed interval AB, and if f is differentiable in open interval AB, and if it is continuous in closed interval AB, then there exists some point C belonging to, open interval AB such that FB minus FA over B minus A is equal to F dash. FB minus FA over B minus A, FB minus FA over B minus A, this is equal to F dash C. If that is so, that if f dash x is greater than 0 for every x in open interval AB, then this would be greater than 0. And this means that fb minus fa would be greater than 0. This would imply that fb is greater than fa. This tells you, see, firstly, I'll define what is meant by monotonically increasing function, but the idea has come from the Lagrange's mean value theorem. Firstly, what is an increasing function? A function is said to be in an interval I. Suppose f is defined in an interval I may be any interval, say closed interval, open interval, any interval. But say f is said to be increasing in the interval I if x1 less than x2 implies fx1 less than or equal to fx2. x1 and x2 belonging to I. Likewise, we can talk about, this is first definition, increasing. Second, strictly increasing. Strictly increasing. This means that x1 less than x2 implies fx1 is strictly less than fx2. x1 and x2 of course belong to I. Strictly increasing. Third definition, this is decreasing. Decreasing is x1 less than x2 implies fx1 greater than or equal to fx2. And again, strictly decreasing, strictly decreasing if the x1 less than x2 implies fx1 strictly greater than fx2. And f is said to be monotonic if it is either increasing or decreasing, right? Combining all these, f is said to be monotonic if it is either increasing or decreasing. Right? Correct or not? But again, I say that if we consider, say, any interval, and if we consider, say, Lagrange's mean value theorem, this tells you that suppose I is some interval, and if f dash x is greater than 0 for every x belonging to I, then f is going to be strictly increasing. Correct? My first observation via Lagrange's mean value theorem says that if f dash x is greater than or equal to 0, then f is increasing in an interval I. If f dash x is strictly greater than 0, then it is strictly increasing in I. Right? See, first observation, this is all right. I'll give you examples, but in any case, these are the definitions. See, my first observation, my first remark, again, via Lagrange's mean value theorem, that is my first remarks. First one, that if f is differentiable in I, that I always assume, differentiable in I, and if number one, f dash x, this is greater than or equal to 0 for every x, then f is increasing in I. Second, if f dash x is strictly greater than 0 for every x, then f is strictly increasing in I. Increasing in I. Third, if f dash x, this is less than or equal to 0, this implies decreasing. And if f dash x is strictly less than 0, this implies strictly decreasing. Right? This implies strictly decreasing via Lagrange's mean value theorem. Let's see the composite of two functions. I observe that if f dash x is strictly greater than 0, and if there is an interval and f dash x is differentiable at every point in the interval, and f dash x is strictly greater than 0, this implies that f is 1, 1, injective, and therefore f is invertible also. Say, if there is an interval I, my fourth observation is that f dash x is greater than 0 for every x belonging to I, then f is invertible, because it becomes 1, 1. In fact, it becomes strictly greater than 0. Then f is invertible. And of course, f inverse also becomes, see, invertible means f inverse. F inverse also becomes, say, and see, a monotonic. More things to come. Let me see composite. G composite F. G composite F. See, what are the possibilities? The possibilities are that F is increasing and G is increasing. Second possibility that F is increasing and G is decreasing. Third possibility that F is decreasing, G is increasing. Fourth possibility that F is decreasing and G is decreasing. Then what happens to? Correct. These are the various possibilities. F is increasing and G is decreasing means x1 less than x2 implies fx1 strictly, they are increasing strictly, fx1, this is less than fx2. And G is also so, this means G of fx1 is less than G of fx2. This means that is G composite f of x1, this is less than G composite f of x2. This means strictly. I'm taking all of them to be strictly. This means when f is increasing, G is decreasing, then G composite, increasing, then G composite f is also increasing. Come to this. You see, x1 less than x2, this implies that fx1 less than fx2, but then this implies G of fx1 greater than or equal to G of fx2. Correct or not? That is, G composite f of x1 is greater than or equal to G composite f of x2. Strictly. I'm taking strictly, so it is so. This shows that G composite f is decreasing, strictly decreasing. This implies that G composite F is strictly increasing, and this implies G composite F is strictly decreasing. Come to this again. This means x1 less than x2 implies fx1 greater than fx2, and since G is strictly so, this means G of fx1 is greater than G of fx2. That is G composite F of x1. This is greater than G composite F of x2. Correct or not? This implies that G composite F, this is decreasing. Come to this, F is decreasing, G is decreasing. X1 less than X2 implies fx1 greater than fx2, but then this implies G of fx1 is less than G of fx2. So surprisingly, this implies that G composite F is increasing. These are the possibilities. है ना? देखें ना? Increasing, 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 decreasing, decreasing, increasing. And if one of them is decreasing, then the result is decreasing. देखो ना? So strange बात है. Strange कौन सा? Fourth result. Fourth is strange. See, consideration of monotonic function also leads to discuss some of the inequalities. अभी मैं आपको ना पहले छोटी inequality से शुरू करता हूँ. Simple inequalities. Say x and sin x. I compare x and sin x in the interval say 0 to pi by 2. I consider this. ये कर दो ना अपना. इसको बंद कर. Look at this. I say that first one, inequalities. I will come to bigger inequalities, but let me begin with this only. I prove that sin x, this is always less than or equal to x for every x in the interval 0 to pi by 2. Let us see how. If I am to talk about this inequality, which way I am to prove? You see, I consider the function gx is equal to x minus sin x over 0 to pi by 2 over this. What I find, g0 is 0, right? g0, this is equal to 0. Correct or not? And what is g dash x? G dash x, this is equal to 1 minus cos x. Whatever may be, cos x is always less than or equal to 1. This means this is equal to, this is greater than or equal to 0 for every x belonging to 0 to pi by 2. This means, therefore, g is increasing in 0 to pi by 2. ठीक है ये बात. But G0 is 0. But G0 is 0. But G0 is equal to 0. Therefore, I obtain Gx is greater than or equal to G0 for every x lying between 0 and pi by 2. Therefore, x is always greater than or equal to sin x for every x belonging to 0 to pi by 2. This is one of the smallest inequality, you know. I'll come to bigger. ठीक है ना. कोई भी आपको इनइक्वालिटी प्रूव करनी हो या किसी फंक्शन को मोनोटोनिकली इंक्रीजिंग प्रूव करना हो, है ना, कोई भी किसी फंक्शन को, जैसे ये मैं आपको एक एग्जांपल देता हूं कि look at this example. X cube minus 2x square, ये 3 कर दो, 3x square plus 10x minus से 99. 10x को भी आप कर दो 15x minus 99. चलो ये मैंने खुद ही अभी बनाया आपके सामने, अभी बतलाता हूँ आप कैसे बनाया. Prove that this function is monotonically increasing in every interval. Prove that this function is monotonically increasing in every interval. क्या करोगे आप? Consider this function fx is equal to this. Take f dash x. This is equal to 3x square minus 6x plus 15. ठीक है ये बात. This means 3x square minus 6x plus 12 plus 3. इसमें से 3 कॉमन, x square minus 2x, ये 3 ले लो, 3 plus 12, 2x plus 1 plus 12. This means 3 into x minus 1 whole square plus 12. अब देख लो ये आ गया. What does this mean? What does this mean? This means f dash x is greater than 0 for all x. The way I have constructed the whole thing. This means, ठीक है, correct नहीं बात. This means f dash, क्योंकि ये देखो ना, ये इस एक्सप्रेशन को देखो आप फाइनली. 3 into x minus 1 whole square plus 12 for all x. This means f dash x is greater than 0, whether x is negative, whether x is positive, f dash x is greater than 0 for all x. ठीक है, चलो और क्वेश्चन करते हैं फिर, है ना. अब बड़े बड़े क्वेश्चन करेंगे. Let's see the first one. Two x square minus log x mod. Let's see about this function. What is to be talked about? See, the thing to be talked about is that it is increasing in some interval, you know. Let us consider a question. Find out the interval, you know, in which it is increasing. 2x square minus log of x mod. What is the domain of this function? By the way, what is the domain of this function? Domain of this function is minus infinity to 0 union 0 to infinity. Correct or not? ठीक है नहीं बात क्यों जी नहीं पर आप थोड़ा ठीक है ये बात because x mod has to be greater than 0 है ना. So domain of this function is this. I consider, so I write this is equal to 2x square minus log of x mod. This means fx is equal to 2x square minus log of x if x belongs to 0 infinity, and this is equal to 2x square minus log of minus x if x belongs to minus infinity 0. Okay. Let me see f dash x. F dash x is over here is equal to 4x minus log of x is 1 by x if x is greater than 0, and f dash x, this is equal to 4x minus plus, and minus finally it would be minus x, minus and then differential coefficient of minus x is minus 1, so it is this. Again, if x is less than 0. In any case, f dash x becomes equal to 4x square minus 1 by x, whether x is greater than 0 or whether x is less than 0. Okay? Whether x is greater than 0 or whether x is less than 0. And this means if x is positive, this is positive always, and that means 4x square minus 1 would be positive. This means 4x square, this is greater than 1, that is x square is greater than 1 by 4. This means x belongs to minus either 1 by 2 plus infinity, 1 by 2 plus infinity, when x is greater than 0. See, greater than 1 by 2 plus infinity. And, when x is negative, this means 4x square minus 1 less than 0. This means 4x square is less than 1. That means x square is less than 1 by 4. This means once again x is less than minus 1 by 2. Meaning thereby, what is the answer? This is minus 1 by 2 union 1 by 2 to infinity. This is the answer. That f is increasing in this domain. ठीक है ये बात? ठीक है ये बात? हैं? देखो नहीं ठीक. What I want to find out about this function where it is increasing. Find out that see subset of real numbers where it is increasing. What I have done, I have considered this function 2x square minus log of x mod. Then I have seen that this is equal to log x if x this, and right up to this line everything is fine. Up to this line everything is fine, right? Then I've talked about the derivative. Firstly, differentiate this. 4x minus log x is minus 1 by x if x is greater than 0. Then talk about this. 4x minus 1 by x, then differential coefficient of minus x again. So that means in any case it is 4x square minus 1 by x. This is the derivative whether x is greater than 0 or whether x is less than 0. Correct or not? You see, f would be increasing where f dash x is greater than 0. So I observe if x is greater than 0, because the domain is this. That means if x is 0 to infinity, from 0 to positive, meaning thereby positive, x is positive. So f dash x would be greater than 0 when 4x square minus 1 is greater than 0. So 4x square minus 1 is greater than 0, where I have written here. 4x square minus 1 is greater than 0, means 4x square is greater than 1, means x square is greater than 1 by 4, means x is greater than half. So when x is greater than 0, that means it is this only. And when 4x square minus 1 less than 0, because when x is less than 0, that means I want the place where it is less than 0. है ना, तभी तो नेगेटिव ओवर नेगेटिव पॉजिटिव हो जाएगा. ठीक है, समझ आ गई ना बात. ये देखा है मैंने कि ऊपर वाला फिर नेगेटिव होना चाहिए, है ना. So this means this thing. This means x is less than minus half. Less than minus half means minus infinity to minus half, and greater than half means half to infinity. That means it is in this domain where the function is monotonically strictly increasing, and in the complement, कौन सा complement है इसका? Minus half to half. It is decreasing. It is increasing in this and decreasing. It is monotonically increasing in this, and between minus half to half, it is monotonically decreasing. ये आंसर है इस क्वेश्चन का. ठीक आ गई बात समझ? क्यों जी? करेक्ट है? चलें आगे. चलो लेट अस सी. नेक्स्ट क्वेश्चन देखते हैं. Let me prove x. You want to say something to me? X is greater than log 1 plus x. For all x greater than 0. Let us see. X is ये जो आपके पास है, इसमें से कोई क्वेश्चन आपको डिफिकल्ट लगता है? कोई जो सबसे डिफिकल्ट लगता है वो मुझे दिखाओ जरा. मैं यहाँ करता हूँ आपके सामने. चलो, द फर्स्ट वन लगता है तो आप पूछ लो, कोई बात नहीं. जो डिफिकल्ट लगता है पूछ लो. आप पूछना चाहते हो? नहीं तो मैं अपनी मर्जी से कराऊं. आप कुछ पूछना चाहते हो तो पूछ लो आप. देखो, व्हाट आई वांट टू प्रूव. Whenever you want to prove such inequalities, x is greater than log 1 plus x. For all x greater than 0. मान लो ये आपको प्रूव करना है. How to proceed with the things, you know. जब भी इस टाइप का क्वेश्चन हो, आप क्या करो, इन दोनों का डिफरेंस ले लो आप. Consider the function fx is equal to x minus log 1 plus x. F dash x is equal to 1 minus 1 over 1 plus x. ठीक है? This means x over 1 plus x. बस क्लियर हो गया. This is greater than 0. For all x greater than 0. Right? But what is f0? F0, when I put x is equal to 0, see, I find that this is equal to 0. Therefore, fx will become greater than f0 for all x greater than 0. This means x is greater than log of 1 plus x for every x greater than 0. ये ठीक है. चलो एक और देखो आप, इसी टाइप का. questions of the same type. You see, this is 1 minus x. Next question. 1 plus x log x plus x square plus 1 is always greater than or equal to 1 plus x square for all x greater than or equal to 0. So what is that I told you? Consider this function. Consider the function fx equal to 1 plus x log x plus x square plus 1 minus 1 plus x square. Fx is equal to this, and what about this function? F0 is equal to 0. You can see when I put x is equal to 0, it becomes equal to 0. So what is f dash x? F dash x, this would be equal to, of course, 0. X means log x plus x square plus 1 plus x over x plus x square plus 1 into 1 plus half x square plus 1 into 2x minus half 1 plus x square into 2x. यही होगा ना? ठीक है ना? यही होगा ना? This means log x plus x square plus 1 plus this will cancel out, and this means this also would cancel out. That is all. This would be there. Log of x plus x square plus 1. And for all x greater than or equal to 0, this is, greater than or equal to log of 1, and this is greater than or equal to 0 for all x. That settles the issue. ठीक है ये बात? This is going to be greater than or equal to 0, and so this, ठीक है ना? Because when x is greater than or equal to 0, this is so. X plus x square plus 1 under root is going to be greater than or equal to 1 for all x, and log increasing function, so it is so. चलो एक देखो inequality. Cos x minus next. We have to prove that cos x is greater than 1 minus x square by 2 whenever x lies between 0 and pi by 2. Prove that cos x is greater than 1 minus x square by 2 for all x in the first quadrant, x greater than 0 and less than pi by 2. तो क्या करोगे जो अभी मैंने बताया है? What you would do? You will consider difference of these two. So you consider the function fx is equal to cos x minus 1 plus x square by 2 over the interval say 0 to pi by 2. What is f of 0? F of 0 is 0. F is differentiable. F is differentiable also. Let me see what is f dash x. Minus sin x plus x. Although that is not the part, but I have already proved it. That if I consider gx to be equal to x minus sin x, then g dash x is 1 minus cos x. G0 is equal to 0. This is always greater than or equal to 0. That means x minus sin x therefore is greater than or equal to 0. This means this is greater than or equal to 0. This means and strictly greater than 0. In fact, you see when x lies between 0 and 1, when x is greater than 0 and less than pi by 2, see less than pi by 2. So this is when x is greater than 0 and less than pi by 2. That means cos x is greater than 1 minus x square by 2. ठीक है ना? क्लियर हो गया ना? क्या होता है कई बार ना सेकंड डेरिवेटिव पर जाना पड़ता है. आई मीन 2 times डिफरेंशिएट करना पड़ता है to find out the reality, because see the function itself comes in terms of another function for which we do not know the inequality. Then we have to again assume that and do the differentiation once again. ठीक है ना? Clear? Next. देखो ये इंटरेस्टिंग क्वेश्चन है जरा देखो जरा. An interesting problem is that if next question, if ax square plus b by x is greater than or equal to c for all x greater than 0, then show that 27 ab square is greater than or equal to 4c cube given a and b they are greater than 0. This also see question of the same type, inequalities, for all x greater than 0. What is that we have to do? We consider the function fx is equal to ax square plus b by x minus c. This means f dash x 2ax minus b by x square, which is equal to 2a by x square into x cube minus b by 2a. See, when f dash x would be equal to 0, f dash x would be equal to 0. If f dash x is equal to 0, then we'll have, for x greater than 0, of course, x cube is equal to b by 2a. This means x is equal to b by 2a raised to power 1 by 3. At this point, that means this point x by b by 2a raised to power 1 by 3, where f dash x becomes equal to 0. See, this means that this is one of the points in the domain. Let me substitute that. X is equal to b by 2a raised to power 1 by 3 means a b by 2a raised to power 2 by 3 plus b 2a by b raised to power 1 by 3 is greater than or equal to c. What this becomes equal to? B by 2a, this becomes a 1 by 3 into b 2 by 3 over 2 raised to power 2 by 3 plus b 2 by 3 a raised to power 1 by 3 into 2 raised to power 1 by 3 is greater than or equal to c. This means this will be 2, 2, and this will be 3. This means 3 a raised to power 1 by 3 b raised to power 2 by 3 over 2 raised to power 2 by 3. This is greater than or equal to c. What is the time to prove? It would be 27ab square. That means cubing both sides. Cubing both sides, it would be yes. This means 3 a raised to power 1 by 3 b raised to power 2 by 3 is greater than or equal to 2 raised to power 2 by 3 into c. Cubing both sides, 27a b square is greater than or equal to 8c cube. This is the answer. ठीक है, समझ आई ये बात? You got it? See, I found out the point where x f dash x becomes equal to 0. That point, if I substitute, I get the result. That point, if I substitute, then I get the result immediately. Huh? Show that 27ab square. अच्छा 4 है ये 2 रेज ओहो सुनो 4 ही आएगा. ये 2 रेज पर इसको क्यूब करोगे ना आप तो 2 रेज पर 2 आएगा. क्यूब नहीं आएगा, ये 4 आएगा. हाँ 4 आएगा. ये क्यूबिंग बोथ साइड्स है ना, 2 रेज पर 2 आएगा. ओ मैं 2 रेज पर 3 कर दिया, आएगा 2 रेज पर 2. समझेंगे ना? 2 रेज पर 2 है. व्हेन यू क्यूब 2 रेज पर 2 by 3 इट इज 2 स्क्वायर. 2 raised to power 2 by 3. When I cube, it is 4. It is 4. ठीक है ना? चलो देखो जरा इस फंक्शन को कंसिडर करो. कब कहाँ इंक्रीजिंग है, कहाँ डिक्रीजिंग है. कर दो ना रब इसको. क्वेश्चन, सम क्वेश्चन. Please explain again. अच्छा. This question, same. Look what I wanted to show. Ax square plus b by x, this is greater than or equal to c for all x greater than 0. I wanted to show that inequality, right? 27ab square is 4 greater than or equal to 4c cube. I wanted to show this inequality, right? I wanted to find out some point in the domain. It is for all x greater than 0. Okay. What I did was that I considered this function ax square plus b by x minus c. And I found out that point where derivative becomes equal to 0. Right? See, that point came out to be b by x is equal to b by a raised to power 1 by 3. That point is in the domain because b and a both are given to be greater than 0. Therefore, b by 2a raised to power 1 by 3 and also that is also in the domain. I substituted that and then simplified and I got the result. That is the whole thing. The whole thing is that I wanted see that some point in because I am given that this is greater than 0 and I am to show this thing, right? So some point in the domain I found out what is f dash x is equal where f dash x becomes equal to 0, and that point is this b by 2a raised to power 1 by 3. This is the point in the domain because this is given to me for all x greater than 0. In particular for this x, when I substitute, simplify, I get the result. राइट ओके क्यों जी कैसे पता लगे कि इनको समझ आ गया हैं हाँ चलो कोई बात नहीं I consider this function now. Function fx is equal to, and I prove. Let me find out where dy by dx becomes greater than 0 or less than 0. Function y is equal to, let's see, y is equal to x cube into x minus 2 whole square. So let's see what is dy by. This is a polynomial and therefore it is differentiable everywhere. है ना देखते हैं कहाँ ये इंक्रीजिंग है कहाँ ये डिक्रीजिंग है ना यही dy by dx this is equal to 3x square into x minus 2 whole square plus x cube into 2 into x minus 2, which means x square, so x square common, x minus 2 common into 3 x minus 2 plus 2x, which means x square into x minus 2, 5x minus 2, 5x minus 6, 6. 5x minus 6. चलो देखो जरा x 0 2 6 by 5 यही मतलब हुआ ना this is x square 5 into x minus 2 into x minus 6 by 5. देखो ना जब भी आपको डिस्कस करना हो ना तो ऐसे कर दिया करो 0 6 by 5 and then 2 divide कर दिया when x is less than 0 this is negative 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 positive, this is positive, so this is positive, this means monotonically increasing over here. When x is between 0 and 6 by 5, you see This is positive now. In any case, this is going to be positive. 0 is 6 by 5, less than 6 by 5, negative. See, x is less than 6 by 5, negative, negative. So this is positive, therefore increasing. When x is greater than 6 by 5, positive, negative, positive. This means negative. And when x is greater than 2, this is once again positive. That means between minus infinity to 6 by 5. See, only see at x is equal to 0. This is f dash x is equal to 0. In any case, f dash x is, greater than or equal to 0. When for all x less than 6 by 5, and also when x is greater than 2. ठीक है, समझ गए ना आपको बात? थ्री एक्स माइनस, हाँ जी, 5x माइनस, देखो जरा, if x is negative, 6/5 से बड़ा होगा और 2 से छोटा होगा. हाँ, 6/5 2 से छोटा होगा, ठीक है ना. तो इसलिए मैंने वो सारी पॉसिबिलिटीज आपको दिखाई ना करके. 2 से छोटा होगा, तो इसलिए उसका, हाँ 2 से बड़ा हो जाए फिर तो पॉजिटिव और नेगेटिव ये है. 2 से छोटा होगा. चलो और देखते हैं. ठीक है, ये थोड़ा अच्छा क्वेश्चन है, थोड़ा लंबा भी है, थोड़ा अच्छा है. See, I consider the interval 0 to pi by 2. Consider the interval 0 to pi by 2. I consider the function 2x. I am to show that 2 sin x plus tan x, this is greater than or equal to 3x whenever x lies between 0 and pi by 2. And if I show more, this is 2 sin x plus tan x. This is strictly greater than 3x when x is greater than 0 and less than pi by 2. चलो ये दोनों ट्राई करते हैं, वो देख लेंगे 0 पर 0 है तो, है ना? देखते हैं, ये उतनी आसानी से तो नहीं आएगा, बट लेट अस सी हाउ इट कम्स. जैसे मैंने आपको बतलाया, आई कंसिडर द फंक्शन एफ एक्स इज इक्वल टू 2 sin x plus tangent x minus 3x. Consider this function over the interval 0 to pi by 2. दोनों पर. ठीक है, ठीक है. What is f0? f0 is 0. तो tan भी 0 है, sin भी 0 है, वो तो 0 है ही. So f0 is 0. What is f dash x? This is 2 cos x plus secant square x minus 3. अब इससे तो कुछ क्लियर नहीं हो रहा ना, है ना, कुछ भी नहीं क्लियर हो रहा. But let us see. This means 2 cos x plus secant square x minus 1 minus 2. Secant square x -1 -2, है ना. This means 2 cos x -1 माइनस secant square x 1 प्लस tan square x, तो ये आ गया tan square x -2, है ना. माइनस कॉमन लिया ना, तो 1 माइनस secant square x -1 1 प्लस tan square x प्लस आया ये, है ना. प्लस आया, प्लस आया. तो अब तो आ गया शायद cos x -1. cos x नेगेटिव ने अभी भी नहीं आया. चलो अभी नहीं आया ना, कोई बात नहीं, आप ऐसे करो, इसी को कंसिडर कर लो. सी लेट gx बी इक्वल टू, कोई बात नहीं, इसी को कंसिडर कर लो, 2 cos x प्लस secant square x -3, इसी को कंसिडर कर लो आप. ठीक है. कंसिडर दिस फंक्शन gx. व्हाट इज g डैश x? g डैश x इज इक्वल टू -2 sin x plus 2 secant x into secant x tan x this means -2 sin x plus 2 sin x by cos cube x. ठीक है. This means 2 sin x into 1 by cos cube x -1. This means 2 sin x 1 minus cos cube x by cos cube x. अब तो ठीक है. इंटरवल तो फर्स्ट क्वाड्रेंट है ना, फर्स्ट क्वाड्रेंट है. π/2 को बेशक हटा ही दो, यहां से हटा दो, x ग्रेटर देन 0 ये हटा दो. क्यों? वो π/2 नीचे आ गया ना, cos वहां ट्रबल करेगा ये. तो x ग्रेटर देन 0 लेस देन π/2, तो यही फिर यहाँ भी ऐसे ही बना दो. π/2 ले ही नहीं रहे. नो व्हाट डू यू से अबाउट दिस? फर्स्ट क्वाड्रेंट साइन पॉजिटिव cos पॉजिटिव, cos cube x cos x is less than 1, cos cube x is also less than 1. This means 1 minus cos cube x is positive, so everything is positive. This is going to be positive always. Whenever x is greater than 0, x is greater than 0 and less than π/2. In this, ये पहले वाला हटाई बस. This is what we are considering, you know. That means इसको इंटरवल को हटा दो, ये. ठीक है. So this is greater than 0, right? So f is g is monotonically increasing. This means, but g0 is equal to ये 2 or 1 3 0. That means gx is greater than 0. When gx is greater than 0 means f dash x is greater than 0. That means f0 is 0, f is monotonically increasing. That means this is so. ये आ गया आपके. आर्गुमेंट आपको क्लियर हो गया तो बतलाओ. क्या किया मैंने कि अल्टीमेटली जी पर चला गया मैं, है ना. उसको कंसीडर कर लिया कि उसको शो करना था ना. बीच में कई बार क्या होता है प्रॉब्लम्स में ना, प्रॉब्लम्स में एक प्रॉब्लम आए थे कि वो नहीं पता लगता कि ग्रेटर देन 0 है कि लेस है. उसी को कंसीडर कर लो, दोबारा उसको कर दो आप. हैं? ये जो है ना क्वेश्चन इन क्वेश्चन यू सी, है ना. चलो नेक्स्ट करते हैं. लेट अस सी y is equal to x square. अब एक्सपोनेंशियल दे. ठीक है, ये रब कर दूं मैं. come to next problem. चलो ये देखते हैं जरा. Question is written as fx is equal to x e raised power ax for all x less than or equal to 0 and x plus ax square minus x cube for all x greater than 0, a is given to be greater than 0. Then show that f dash x, this is increasing in the interval minus 2 by a comma a by 3. देखते हैं पहले तो इसको डेरिवेटिव निकालना भी. Let us see what is f dash. See, f is differentiable when x is less than 0 and f is differentiable when x is greater than 0. But let me check at x is equal to 0. Then I can say f dash x. This is because 0 is also occurring over here. That means in this interval. That means f should be differentiable. Let me see left hand derivative. See, x e raised power ax for all x less than 0 and x plus ax square minus ax cube when x tends to 0 from right, x plus ax square minus x cube divided by minus 0. At x is equal to 0, it is 0. So 0 divided by x minus 0, limit of this when x tends to 0 from positive side. This is right f dash 0, right hand derivative. Right hand derivative, this is going to be equal to, ये सब तो जो है ना, this is equal to 1 आ जाएगा 1. And left hand derivative when x tends to 0, this is fx minus f0 is 0 divided by x when x tends to 0. Left hand derivative is also equal to 1. Correct? ठीक है ये राइट हैंड डेरिवेटिव और लेफ्ट हैंड डेरिवेटिव निकाला. देखो ना, दिस fx minus f0 divided by x minus 0, limit of this when x tends to 0 from positive side, and limit of fx minus f0 over x minus 0 when x tends to 0 through negative side. ये इसमें क्या सब्स्टिट्यूट करेंगे, इसमें ये fx is this f0 over x minus 0, x tending to 0, so x tending to 0 minus 0 this, and what about that, it is x e raised power ax minus 0 by x when x tends to 0, this also tends to 1, this also tends to 1. ठीक है. This means f dash, f is differentiable everywhere. पहली first observation, f is differentiable everywhere. ठीक है. And f dash 0, this is equal to 1. इसको कर दूं अब मैं, क्योंकि उसकी वैल्यू लिखूंगा अब मैं. So f is differentiable everywhere. F is differentiable everywhere and f dash x is equal to e raised for ax plus ax e raised for ax when x is less than 0, it is 1, x is equal to 0, and it is 1 plus 2ax minus 3x square when x is greater than 0. Yeah, f dash x. समझ आ गई आपको बात है? उसका मैंने सेपरेट निकाला है लेफ्ट हैंड डेरिवेटिव. बट आई एम टू शो f dash is increasing in every interval. इसका मतलब मुझे f double dash की बात करनी है ना, कि आई एम टू शो in which interval f double dash x is greater than 0, वो फाइंड करना है. Let me find out f double dash x. f double dash x when x is less than 0, वो तो ठीक है कर दूं रब मैं. सिर्फ इसको f dash x को नहीं रब करता, बाकी सबको रब करता हूँ. पहले ना f डबल डैश 1 निकाल लूं मैं. सी f dash 1 x minus f dash 1 by x minus 0, f dash 0, this when x tends to 0, from what? From left hand side. This is equal to e raised for x zero, f dash x is e raised for x, e raised for ax plus ax f dash x, ax e raised for ax, e raised for ax over ax, and when x is 0, this is 1. तो क्या है 2a minus this when x is less than or equal to 0 over x when x tends to 0. So 1 plus ax minus भी तो लिखना है, minus this f dash x, plus f dash 0. F dash 0 is 1. F dash 0, f dash x minus f dash 0 is 1, minus 1 over x. है ना, यही करना है ना. f dash x minus f dash 0 is 1. ठीक है. So this means e raised for ax यहाँ से outside, this is minus 1, e raised for ax minus 1 by x plus a e raised for ax, है ना. This is 1 plus ax, तो a आ जाएगा ये. This would be what? This would be, देखो जरा ये क्या आएगा, because e raised for ax is equal to 1 plus ax whole square by 2, etc. So when x tends to 0, this would be when x tends to 0, this would be equal to 1 आएगा ना. ax a आ गया, e raised for ax a into this and this tends to 1, so this tends to a2 2 आया, ये आया जी। समझ गए कैसे निकाला मैंने? देखो आपको बतलाता हूँ मैं, आप कहीं कंफ्यूज ना हो। ये दिस इज, ये निकालना था मेरे को, e raised power ax plus ax e raised power ax minus 1 f dash 0 was 1 by x. This means firstly e raised power ax minus 1 by x plus a into e raised power ax, ठीक है, which means e raised power ax minus 1 by ax into a plus a e raised power ax, ये किया। When x tends to 0, है ना, you see whenever you have limit of e raised power theta minus 1 by theta, when theta tends to 0 is always equal to 1, ये होता है, is always equal to 1. So इससे a what is the answer? This is 2a. उसी तरीके से जो है ना राइट हैंड साइड, सो क्या आता है फाइनली मैं आपको बतलाता हूं, ये आप समझ लो आप। दिस मीन्स f डबल डैश x, what is f double dash x? F double dash x becomes equal to f double dash x becomes equal to this thing, ये आप नोट कर लो, 2a e raised power ax plus a square x e raised to power ax for all x less than or equal to 0, and just 2a minus 6x for all x greater than 0. ये देखो ना x is equal to 0 पर 2a ही है, ये जो मैं कह रहा था, at x is equal to 0 f double dash 0 is 2a. ठीक है, so now f dash x would be increasing. Now f dash x is increasing if what happens? If f double dash x is greater than 0. This means 2a into e raised power ax plus a square x into a raised power ax. This would be greater than 0 for all x. That means, and 2a, this means what? 2a plus ax. 2a, a भी कॉमन आ गया ना, a into e raised power ax भी कॉमन, ये सब पॉजिटिव है, 2 plus ax, this is greater than 0, and therefore a is greater than or equal to x is greater than or equal to minus 2 by a, and of course x for all x when x is less than 0, है ना, ये तो when x is less than 0, this is for this case when x is less than 0, and x is greater than 0 means 2a minus 6x is greater than 0. This means a is, see, x is greater than 0 of course and less than a by 3. That means finally क्या है, minus 2 by a and a by 3. This is the interval. ठीक ठीक है, समझ आ गई बात कि नहीं समझ आई? f डैश x निकाला ना मैंने, उसके बाद क्या किया मैंने, फिर f डबल डैश x की बात की है। f डबल डैश x कहाँ ग्रेटर देन 0 ये देखा है मैंने, बस किस इंटरवल में वो ग्रेटर देन 0 है। कि व्हेन x इज लेस देन 0, ये कब ग्रेटर देन 0 है? ये वाला ये देखो यहाँ है। और व्हेन x इज ग्रेटर देन 0, तो ये कहाँ ग्रेटर है? दैट मीन्स ये इंटरवल। ठीक है ये बात। और करते हैं प्रॉब्लम। चलो ये देखो, ये भी एक अच्छा इंटरेस्टिंग क्वेश्चन है, कराता हूं मैं आपको। कर दूं अब ये? Suppose I am given that f is an increasing function. Question. Discuss the nature of hx fx minus fx whole square plus fx whole cube. Nature of this, given nature of f. f की नेचर दी हुई है, इसकी डिस्कस करनी है। तो कैसे डिस्कस करेंगे? उसी तरीके से जैसे डेरिवेटिव निकालना है। h dash x is f dash x minus 2fx into f dash x plus 3fx whole square into f dash x. This means f dash x into 3fx whole square minus 2fx plus 1. ठीक? Which means f dash x in by 3 into fx whole square minus 2 by 3 fx plus 1 by 3, which means 3 f dash x into fx whole square minus 2 by 3 fx, यहाँ कितना आना चाहिए? 1 by 9 आना चाहिए। Then 1 minus 3, 1 by 3 minus 1 by 9, तो 2 by 9। ठीक ठीक क्यों जी? ठीक है। क्या कर रहा हूं मैं? ये क्यों कर रहा हूं? उसको परफेक्ट स्क्वायर बना रहा हूं मैं। दिस मीन्स 3f dash x into fx minus 1 by 3 whole square plus 2 by 9। तो क्या आया? बोलो जी, क्या आया? क्या आंसर है मेरा? ये मैंने कर दिया तो क्या आया? इसका मतलब यह देखो, ये आंसर आया कि इफ f is increasing, strictly increasing, then h is also strictly increasing. And if f is strictly decreasing, then h is also strictly decreasing, provided of course with the assumption that they are differentiable, f is differentiable, etc. etc. समझ गए बात? समझ गए बात बिल्कुल, क्योंकि f डैश x ग्रेटर देन 0 होगा। अंदर तो पहले मैंने ग्रेटर देन 0 बना दिया, वो परफेक्ट स्क्वायर बनाकर ना अंदर बना दिया मैंने। ठीक है कि नहीं? एक जरा और देखो, fx is equal to e raised power x fx is equal to e raised power x, question, fx is equal to e raised power x into x minus 1 into x minus 2 to show f decreases in the interval 1 2। कैसे शो करोगे जी? ऐसे ही करोगे कि f डैश x उसका बतला दोगे इसमें है कि नहीं है ना? देखो जरा, e raised for x into x minus 1 into x minus 2, so f decreases in 1 2, f dash x is e raised for x into x minus 1 into x minus 2 plus e raised for x into x. क्या है? नहीं नहीं, सॉरी, क्वेश्चन ही गलत है, ये नहीं है, क्वेश्चन कुछ और है, क्वेश्चन कुछ और है। मैं कहा ये तो कुछ और आ गया, एक्स स्क्वायर माइनस एक्स माइनस 1, ये है क्वेश्चन, इंटीग्रल है, ये है क्वेश्चन, क्वेश्चन ये है, क्वेश्चन वो नहीं था, क्वेश्चन ये है। तो सीधा ही आ गया था ना, एक्चुअली वो क्वेश्चन ये था कि एफ डैश एक्स वो था। चलो ये देखो जरा, ये इसको, व्हाट इज एफ डैश एक्स? क्यों जी, आप बतलाओगे मुझे कि एफ डैश एक्स क्या है? हाँ जी, किसको पता कि एफ डैश एक्स क्या होगा? है? तो अगर एफ एक्स इंटीग्रल है ना, तो दिस implies that f dash x, this is e raised power x into x minus 1 into, ये बस, ये क्वेश्चन ये था एक्चुअली, ये था क्वेश्चन कि ex is integral, so f dash x is without integral. So now of course e raised power x तो हमेशा पॉजिटिव है, 1 2 का मतलब है x is greater than 1 and less than 2. When greater than 1 and less than 2, this means this is less than 0 for every x belonging to interval 1 2, and therefore f is strictly decreasing. ठीक है, ये क्वेश्चन था. एक ना और क्वेश्चन आपको मैं करवाना चाहता था, चलो देखो जरा, वो अच्छा क्वेश्चन है. The value of k for which the function, लिखो जरा आप. The value of k, question. The value of k for which the function fx is equal to kx cube minus 9x square plus 9x plus 3 may be increasing the values of k, values of k, these are what? देखो जरा ये इसको कैसे करेंगे. If the function is given to be this, increasing means f dash x should be greater than 0. Let me see what is f dash x. F dash x is equal to 3kx square minus 18x plus 9. ठीक है. This means 3kx square minus 6x plus 3. अब क्या करेंगे. We want the quadratic to be greater than 0. देखो एक बात याद रखो, कोई भी क्वाड्रेटिक कब ग्रेटर देन 0 होता है. If the coefficient of x square is greater than 0 and discriminant is less than 0. ठीक है, ये नोट कर लो. What is to be noted? What is to be noted is that ax square plus bx plus c, this is greater than 0 if a is greater than 0 and b square minus 4ac is less than 0. This means this is k is greater than 0 and b square means 36 minus 12k is less than 0. That is k is greater than 3. This means what is the answer? The answer is the values of this are increasing are k greater than 3. This is the answer. K greater than 3. ये है. एक और क्वेश्चन है इसी टाइप का ही, तो आपको करवाता हूं मैं. चलो ये देखो जी, ये कंसीडर करो फंक्शन. The least possible value of k, question, the least possible value of k for which the function fx equal to x square plus kx plus 1 may be increasing in the interval increasing on 1 to 2 is what? The least possible value of k for which this function, देखो जी सिंपल बात, इंक्रीजिंग है तो f dash x must be greater than 0. So let us see, argue logically. fx is x square, fx is x square plus kx plus 1. Therefore, f dash x is 2x plus k. ठीक है, हाँ जी, -4 नहीं, आंसर -4 तो नहीं है. देखो जरा, 2x plus k, 2x plus k, that has to be greater than 0, नहीं? This means x has to be greater than minus k by 2, है ना? minus k by 2. अब देखो 1 2 में है ये, वो x उसके अंदर लाई करना चाहिए. इसका ना जो लीस्ट वैल्यू जो होगी क्या होगी, ये होनी चाहिए ना कि माइनस k by 2 शुड बी ग्रेटर देन और इक्वल टू 1. ये होना चाहिए ना, है ना? दिस मीन्स k हैज टू बी ग्रेटर देन और इक्वल टू -2, है? तो लीस्ट वैल्यू क्या आई? आप मेरे ख्याल आपने 2 लगाया होना, इसलिए नहीं, वो तो ग्रेटेस्ट हुई ना फिर. नहीं, देखो ना कि है, नहीं वो उसके अंदर लाइन वो लेस देन होना चाहिए फिर, है ना? वो फिर लेस देन होगा फिर, तो लीस्ट वैल्यू इज -2 कि वो उससे, ठीक है ना? समझ गए ना आप? आर्गू तो कर रहे थे ठीक, पर थोड़ा सा वहां फ्लॉप कर गए वो जो है ना. द लीस्ट वैल्यू इज व्हाट? -2. ठीक है. एक जो लास्ट क्वेश्चन अब डिस्कस करते हैं वो है, लेट्स सी वन मोर फंक्शन. Function is 3 cos 4x. Function is 3 cos x plus 10 cos cube x plus 6 cos square x minus 3, और इंटरवल है हमारा 0 to पाई, मतलब फर्स्ट क्वाड्रेंट और सेकंड क्वाड्रेंट. देखते हैं इसकी नेचर क्या है. ट्राई करते हैं f डैश x, है ना? सी f डैश x क्या है? दिस इज 12 cos cube x इंटू माइनस साइन x, ठीक है, प्लस 30 cos square x इंटू माइनस साइन x प्लस 12 cos x इंटू माइनस साइन x. ठीक है. दिस मीन्स क्या कॉमन है? -3 कॉमन है, -3 कॉमन, और cos x भी कॉमन और sin x भी कॉमन, इंटू 4 cos square x, ये 4 cos square x प्लस 10 cos x प्लस 4, तो 2 भी कॉमन है ना, -6 cos x sin x 2 cos square x plus 5 cos x plus 2. This means minus 6 cos x sin x. तो ये फैक्टर करो तो आ जाएगा cos x plus 2 into cos x plus half. इस हाफ में से भी 2 कॉमन लेंगे तो 12 आ जाएगा। ये बन गया जी फैक्टर, ये बने फैक्टर। क्या आपका आर्गुमेंट कहता है? फर्स्ट क्वाड्रेंट है 0 to pi by 2, सॉरी 0 to pi, फर्स्ट क्वाड्रेंट है। It changes sign actually between 0 to pi by 3, then है ना cos 0 1 है ना, cos 0 this is 1, cos 60 cos 60 1 by 2, cos 90 पर 0, उसके बाद फिर है ना वो 1 by 3 0 से फिर जो है ना बिटवीन, इनफैक्ट आप आंसर लिख लो जो है ना, एक्चुअली f dash x is equal to 0 when x is 0 और pi by 3 और 2 pi by 3 या pi, ये चारों पॉइंट्स पर 0 होगा ये। और f dash x this is greater than 0 when x lies between pi by 3 and pi, and this is less than 0 when x lies between 0 and pi by 3। ये है टोटल बात, क्योंकि हाफ के बाद चेंज होता है ना फिर। सो दिस इट इज सो, cos x नेगेटिव आ जाता है जो है ना, राइट? ठीक है, आपको कुछ पूछना है तो पूछिए, आप पूछो, मैं आपकी कोई डिफिकल्टी है तो आपको जो है ना कुछ भी आपको जो कोई दिक्कत होती हो किसी बात में, कोई प्रॉब्लम नहीं है। देखो ये तो नहीं है मैं कहता कि आई विल आंसर है, बट आई विल ट्राई दैट, आई कैन से यू नो। आपको अभी है टाइम, 1 मिनट है, कोई नहीं, इतने में इनसे बात करते हैं जो भी है व्हाटएवर। मैं तो इनको शुरू में भी कहा कि आप मेरे से पूछिए, कुछ पूछना है तो मैं उसी का जवाब पहले दे दूंगा। एनीथिंग व्हिच यू लाइक टू आस्क, अदरवाइज भी कुछ पूछना तो पूछ लीजिएगा। अच्छा, जो मैंने जितना कराया है आज के यही 1-1.5 घंटे में, कोई ऐसी बात है जो आपको नहीं समझ आई हो, एनीथिंग कि आपको कोई ऐसे कुछ कंफ्यूजन था हो, ये कैसे किया मैंने? कुछ है पूछना है? आप बदलाव कौन सा? वो के वाला? देखो क्या है कि वो आया था ना कि दैट वैल्यू x की वैल्यू इंटरवल है 1 to 2, तो लीस्ट वैल्यू तो 1 है ना, कि इससे कम से कम बड़ा होना चाहिए, इससे कम से कम बड़ा होना चाहिए, मतलब सबसे छोटा यही है, है? नहीं ऊपर उसके अंदर तो नहीं आता ना, फिर आना तो 1 और 2 के बीच में है ना, वही तो एक्चुअली पॉइंट था कि द वैल्यू शुड लाई बिटवीन 1 and 2, तो इसका मतलब ये है लीस्ट वैल्यू, इसका मतलब वो, तो इसलिए मैंने आपको कहा कि आपने थोड़ा वो ले लिया ना, अदरवाइज कुछ नहीं था। ठीक है, ओके, डन, ओके, बेस्ट ऑफ लक। हाँ जी क्या है
पेमेंट जो आपको होगी ना इसकी, वो एनईएफटी के थ्रू पेमेंट करेंगे तो आप अपने